With the introduction of functions into our vocabulary, we now need to talk about local and global variables. These two words describe how a variable is used, not the variables themselves. They're always ints or floats or colors or whatever type they are. The variable itself is always the same. Local and global refer to how visible the variable is. Let's start with an analogy. Suppose that you have a bunch of art inside your house, and so you want to refer to it, so one day you talk about the painting of the man with a hat. Well, you're only talking about the art inside your house, and so that's unambiguous. There's only one painting of a man with a hat, and you know what it is you mean. People outside of your house, they don't know what kind of art you have. They can't talk to you about the painting of the man with the hat. They don't even know it exists. They have no idea. They can't see what's inside your house. So the artwork in your house is your private, local artwork. You can refer to it when you're inside the house, but when you're outside talking to other people, they have no idea what you're talking about. By contrast, there's public art, which we'll call global art. And this is art that's available to everyone, everywhere. And so everybody can see this art. And if you say the man with the hat or the little boy who's running, everybody knows exactly what you mean because this artwork is shared among everyone. So these are the ideas behind local and global variables. Local variables are those that are inside, typically, of a function, and they only have meaning inside the function. Global variables exist over the course of the whole program, and they have meaning everywhere in the program. Now, people being what they are, there's an interesting thing that happens with global art. Here's an outdoor mural. After it's been up for some time, I think we all know what tends to happen. In this case, it's defaced. I think we can all agree it's made worse. It's ruined. But leaving value judgments aside, we can certainly say it has changed. If the work is public, anybody, anywhere is free to go up to it and change it. And they do. This is a risk. When you make things available to the public, when you make them globally visible, you run the risk that they can be changed on you without your knowing. On the other hand, it's worth the trade-off sometimes because when something is shared, it can be built up together. If everyone is cooperating, then those shared resources become an asset, and you can, in fact, do wonderful things if you're sharing your resources cooperatively, as opposed to, say, somebody spraying graffiti on a piece of public art. So to summarize our analogies, let's suppose that you have a coloring book. If the coloring book is public, then any kid can come along and scribble in it, and they can do whatever they want to it. If it's private in your own home, in your own library, then only you and your kids and your friends can draw in the coloring book. These both have their advantages and disadvantages. The bottom line is kids are always going to color in their coloring books, and the coloring books themselves don't care where they're kept. A coloring book is a coloring book. But what's different is the accessibility. Can anyone get at it, or just the people in your home? Let's now move from the world of metaphor to the world of programming and take a look at a program. Here's a simple program. The setup just calls size and smooth. In Draw, I just declare 3 variables, give them values, and set the background color. In this example, these are local variables. Red val, green val, and blue val only exist inside of Draw because they are declared inside of Draw. They are declared between the opening and closing curly brace of Draw. We say that Draw is their scope. It is the range of their visibility. If setup or some other routine tried to refer to red val, green val, or blue val, processing would flag that as an error. It would say, I can't see that. Only code inside of Draw can see red val, green val, and blue val. This is both an advantage and a disadvantage. The advantage is we have encapsulation. Nobody else in the program can scribble or change the values of red val, green val, and blue val. The disadvantages, though, are Nobody else can change red val, green val, or blue val. If some other function wants to modify these values, it can't do it because no other function can see these. There's another point which is a little more subtle but very important, which is every time we enter draw, these variables get recreated and reassigned. So there's no memory. Remember, draw gets called by default 60 times a second. Every time we enter draw, at the beginning of the routine, these variables don't exist. Then the first line says red val equals 255. Processing creates some memory to hold red val, and so forth. It finishes the rest of the lines. It hits the closed curly brace, and red val, green val, blue val go away. Then draw gets called again. It says, oh, I need to create a variable called red val, and it makes it again. Now this takes a little time, but very little time, not enough to worry about. The disadvantage is there is no memory. There's no way to remember the values of red val, green val, and blue val from one call of draw to the next. So if draw wants to make red val go down over time, there's no way it can do that using this code because red val goes away when draw exits. What to do? Well, you know what's coming. I've been talking about local and global. If these are local variables, the way to fix it is to use global variables. The way we do that is we just pull the definition of red val out of draw and put it outside of all the routines, just like this. So now float red val, the declaration of the variable red val and its initial assignment, is outside of any pair of enclosing curly braces. It's a global variable, and that means every function, everything in the program can see this variable. Typically, we put these at the very top of the program. It doesn't matter where they are. Processing will find them all, create the memory, assign their values before it runs anything. So I'll just put them here for now, but remember, we usually put them at the top. So I want red val, green val, and blue val to all be globals. So let's move them all out of draw. Now they're global variables. We haven't changed red val, green val, blue val. They're just floats. But we think of them now as globally accessible, and so we call them global variables. Suppose that you were looking at draw and you didn't see the assignment lines immediately above. All you can see is the call to background that uses red val, green val, and blue val. And you would ask yourself, naturally, are these local or global variables? In some programming environments, you can find out just by hovering your mouse over one of the variables, and it will basically let you know one way or another if it's a local or a global. In processing, there's no way of knowing. It's implicit. If the variable is declared outside of any grouping of open and closed curly braces, it's global and everything can see it. If it's not, then it's local. So how can you tell just by looking at a variable? You can't. You have to start scrolling through the source code and look for the declaration of the variable. I have a convention. It's not shared by everyone in the world. It's not even shared by processing. But I've been doing it for years and it works beautifully for me. I capitalize the first letter of any variable if it's a global. So let's take red val, get rid of that little r, and put in a capital R. And then we need to do the same thing where we use it in the background call. And now capital R red val, that's just my little typographical convention to say this is a global variable. This is declared outside of any function. And there's no rule here. There's nothing enforcing this. In fact, the program as it's written right now with red val and with a capital R and green and blue with lowercase letters is perfectly fine. This is 100% A-OK. But for me, and I advise for you, I find this a wonderful convention. Start your global variables with capital letters and then always refer to them with, of course, a capital letter because that's their name. And now when you have something like this and you look at that bottom line, background, red val, green val, blue val, you can instantly see, oh, those are global variables because they begin with a capital letter. So that's my convention. I adhere to it and I strongly recommend you do too. Now that we have global variables, we can use them to remember values over time, from one frame to the next. We'll see how in part 2.